Okay, so here's the quick how to profile Madness applications using the Google Performance Tools. Madness is multi-threaded, so you need a multi-threaded analyzer. Pretty much the only free one that's out there is the one that comes with the Google Performance Tools. And happily, there are instructions online already for how to do that. First, you've got to build Madness with the Google Performance Tools, and those instructions have been in the wiki for a while. Go into the software environment page and follow the instructions there. The key points are you'll need the Google Performance Tools. tcmalloc is their super fast malloc, very impressive. And on a 32-bit computer, which I must admit I've never done, everything should be straightforward to install. 64 bits a little trickier, mostly because of problems with this libunwind thingy that they use in order to get the call tree when they're doing their statistical sampling. So basically, get libunwind going, get graphviz and gv if you don't have them already, download the Google Performance Tools and build them following these instructions. If you're on a 32-bit platform, you won't need the _64 thing there. Okay, so now you've got the Google Performance Tools and everything built. You'll need to build Madness using those tools. The install file for Madness has those instructions. The thing you've got to do is specify the correct libraries option, and here I'm telling it to use MKL, the Google Performance Tools, link against the actual MKL libraries with the multi-threaded stuff, tcmalloc to get the fast malloc, the profiler to get the profiler going, and then the standard C++ library. The Google Performance Tools don't actually do anything unless you set an environment option. I should be sitting in the molecular DFT program directory. You'll obviously be sitting in your own directory. But if, when you're running your program, you set the environment variable CPU profile equal to the name of some output file, and then run your program as normal, you can use MPI if you want, in which case you'll get a profile for each process. Then just run it. I was using bash. If you were using, for instance, a C shell, you'll have to use the appropriate syntax for setting the environment variable. So what's going on is every 100th of a second, Google is interrupting your program, figuring out where it is, and at the end of all of that, it's going to write out that profile, and we're going to have to run another command to look at the data. And they've got a very nice command to do that. In about 10 seconds, we'll get to use it. Dum, 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 dum. Here we go. So pprof is the name of the command. --gv says, please display the results using gv. There's lots of other options. And we now need to give it the name of the executable, which for me was moldft, and the name of the file that we used to contain the profiling. Takes it a while because it's a big file. And wow, you see we get a lot of results. I'm going to shrink them down to fit into the window that you can see. And just got to remember how to use this tool. It actually begins at the beginning of your program and generates the entire call tree going all the way down. We zoom in on actually one of these entries. I can remember how to do it. Well, we'll come up here and zoom in with this, but that's going to involve resizing the window again, making the FOP matrix, this first line says it actually didn't spend any time at all making the FOP matrix inside this routine, but 1.4% of the total time was actually spent off calling some of the children that FOP matrix invoked. And let's find a more expensive routine. Here we go, here's the inner product routine. And it's saying 1.7% of the time was actually spent in this routine, and the remaining 0.2% of the time of the total was spent off in other children that it didn't deign as important enough to mention here. Anyway, I'm sure you can figure out how to use Google to find information on how to use the Google Performance Tools, and I think you should be off and running. Have fun!